So in the previous video, we introduced functions, and hopefully I got you thinking about functions like in terms of this flow chart here and this physical machine that we're taking numbers and putting them into, and the machine does its work behind the scenes in some cases, and other numbers come out. And even though this flow chart might be the way you always want to think about functions, there's three different ways that we'll represent functions in our class. We'll represent them in the standard form with an equation, we'll represent them in terms of tables, although not very commonly, and we'll represent them in terms of graphs. In this video, what I want to do is talk about the two most common questions that you're ever going to get about functions. They both concern inputs and outputs, and really what they are either I'm going to give you the input and ask for the output, or I'm going to give you the output and ask for the input. So if from the previous video you learned some understanding of inputs and outputs, then this won't be too hard. But I want to stress this a little bit because it's really fundamental to everything that we'll do with functions. And also the questions themselves look kind of similar. And in a lot of cases, students can get confused between the two. And even though you're able to accomplish both tasks, you don't know when to accomplish the first versus the second, so you don't end up getting questions right. One more little wrench I'm going to throw into things is these two most common questions. I'm going to ask them three different ways, right? I'm going to ask them if the function is presented to you with standard notation. And then it probably won't surprise you. I'm going to ask you these questions if your function is presented with a table. And then I'm going to ask you these questions if your function is presented with a graph. So without further delay, suppose that our function is given to us to be x squared minus 2x minus 8. Our function is given in standard notation. Our function is given in terms of an equation. This machine f, when the input is x, the output is x squared minus 2x minus 8. What if you were asked to find f of 0? Often the verb that is given is evaluate. So maybe you're told to evaluate f of 0, something like that. What you need to be able to do is look at this and understand that the question is asking you to find f of 0. So it's asking you to find the output. The output for what input? Well, the input is always the thing inside the parentheses here. Taking the place of the x is the number 0. So if you're asked to evaluate f of 0, really what you're being asked is what output would correspond with an input of 0. If you want to go back to our flow chart, we have this machine f, and we're going to feed the number 0 into this machine, and the question is asking what would come out. So how would you figure that out? Well, fortunately, it's pretty easy. If you have this blueprint right here, you have the output for any input x. So if we want the output for this specific input, all we got to do is change all the x's into zeros. F of 0 would be equal to 0 squared minus 2 times 0 minus 8. And let's see, 0 squared is 0, and 2 times 0 is 0. So I get 0 minus 0 minus 8. I get that f of 0 is equal to negative 8. If somebody asked me to evaluate f of 0, I would say that f of 0 evaluates to negative 8. In other words, if I'm putting 0 into this machine, I expect a negative 8 to come out of this machine. And the good news is that if that made sense, the rest of these questions up here, 2, 3, and 4 with Roman numerals for some reason, aren't any harder. If somebody asked you to evaluate f of 2, maybe you'd understand just by looking at this that they're asking you what comes out of the machine when I put 2 into the machine. Well, that's easy. F of 2 would just be equal to 2 squared minus 2 times 2 minus 8. Again, copying the blueprint that you see written up here, except changing all the x's into 2's because my input is the number 2 as given with this notation. I think we've actually already evaluated this one. 2 squared is 4. 2 times 2 is 4. So I have 4 minus 8. I have 0 minus 8. I have negative 8. F of 2 is equal to negative 8. F of negative 5 isn't any harder. It would just be negative 5 squared minus 2 times negative 5 minus 8. I guess you do have to be a little bit careful with your arithmetic here. Negative 5 squared is positive 25, and negative 2 times negative 5 is positive 10. So I'd have 25 plus 10 minus 8. I'd have 35 minus 8. I'd have 27, I guess. F of negative 5 would be 27. The output of 27 corresponds with an input of negative 5 for this machine f. Finally, in the interest of practicing a little bit more arithmetic, there's no reason I couldn't put in a fraction like 1/2 as my input into this machine. F of 1/2 would just be equal to 1/2 squared minus 2 times 1/2 minus 8. Let's see, 1/2 squared means 1/2 times 1/2. And when you multiply fractions, you multiply straight across. So in the top, I would have 1 times 1. And in the bottom, I would have 2 times 2. So 1/2 squared is 1/4. When I'm multiplying 2 and 1/2, it might make life easier to think about this 2 as a fraction. So as a fraction, this 2 is 2 divided by 1. So I have 2 divided by 1 times 1 divided by 2. I multiply straight across, I get 2 over 2, in other words, 1. So from 1/4, I want to subtract 1 and then subtract 8 more. So I have 1/4 minus 9. From a fraction, I want to subtract a whole number. It might help to change these both into fractions. So 9 as a fraction is 9 over 1. To subtract fractions, I need a common denominator. My least common denominator is 4. So I'll multiply the top and the bottom of this fraction by 4 and get 36 over 4, which is the same as this 9. 1/4 minus 36 fourths is negative 35 fourths. In other words, if for some reason I decided to put 1/2 into this machine F, I would expect a negative 35 fourths to be the output from the machine. And yeah, that got a little bit annoying and kind of tricky with the arithmetic, especially if you're not used to multiplying and adding and subtracting fractions and stuff. But really, as far as the new information, what I want you to understand is, if you just see this in some other context, I want you to understand what the question's asking you. If you're asked to evaluate f of 0, maybe, I want you to understand that the question is asking you what comes out of this machine when you put 0 into this machine. And it'd be awesome if you understood that the way to answer that question would be by doing this series of steps. You might be like, yeah, I got it. You kind of beat that to death. You didn't need to do 4 different examples. One would have been sufficient. Well, the reason I want to do a lot is because look how similar this question here looks to this question down here. The second most common of the 2 most common questions looks very similar to the most common of the 2 most common questions. This one up here where I'm asked to evaluate f of 0 looks pretty similar to this one down here where maybe the verb that's most typically used would be like solve. Solve f of x equals 0, something to that effect. But really on the mathematical side of things, what this is saying is that the output, remember f of x represents the output, is equal to 0. Up here, this is telling me that the input equals to 0. The x is 0 up here. Down here, the f of x is 0. Up here, I'm being told the input is 0, and therefore implied is that I want the output. Down here, I'm told that the f of x, the output is 0, so implied is that I want the input. So how do you do that in this case where our function is given by an equation? Well, the good news is we're just going to go back up here again. If you really understand what this is telling you, that the output is the right side of this equation right here, x squared minus 2x minus 8, then all this is saying is the output, that x squared minus 2x minus 8, that's supposed to be equal to 0. And I have to figure out what x is. Well, if x squared minus 2x minus 8 equals 0, I have an equation. And if I could solve this equation for x, then because x represents the input, I'd be answering this question. I would be figuring out the input for this given output of 0. This specific equation is a little bit challenging to solve. Hopefully you've seen it before in some class. There's 3 different options. You can complete the square, you can use the quadratic formula, or you can factor this guy. I think factoring is kind of the cleanest way to do it, so that's how I'm going to solve this. This is what's called a quadratic trinomial with a leading coefficient of 1, meaning there's a 1 out in front of this x squared here. And the way it's going to factor is into a pair of monomials, meaning I'm going to put an x here, and then some number like plus 1 or plus 2 or plus 3 here, and then some other number plus 1, plus 2, maybe minus over here. And I have to pick these 2 numbers so that when I multiply them together, I get negative 8, and when I add them together, I get negative 2. There's lots of numbers that add together to get negative 2, so it makes more sense to focus on what I can multiply together to get negative 8. Well, let's see, 8 is equal to 1 times 8, and it's also equal to 2 times 4. So if I want negative 8, I either have to have negative 1 and positive 8, or positive 1 and negative 8, or negative 2 and positive 4, or positive 2 and negative 4. So I kind of have these 4 options that I'm considering. However, I need the numbers to add to negative 2. There's no way I'm going to sum to negative 2 if these are my 2 choices. I'm going to have to pick these 2. And to make sure that that sum is negative 2, I guess the 4 would have to be negative and the 2 would have to be positive. So I'll put a positive 2 here and a negative 4 here. What I'm saying is x squared minus 2x minus 8 factors to x plus 2 times x minus 4. And if you have a hard time with this factoring, I'm sure you've learned it in some previous class. And if you do it a little bit differently, if you do it with like an X method or like a little hashtag looking thing or some box method or whatever you've learned before that works for you is totally fine for this class. I don't care how you get here. I just want you to be able to get here. At any rate, the advantage of factoring this is now I have something times something equals 0. There's this thing called the multiplicative property of 0, and it only works if the number is 0 over on this side. If this were anything other than a 0, it wouldn't help me to factor like I did. But because this is 0, the only way you can multiply together two things in math and get 0 as the answer is if one of those two things is equal to 0. So from this line, I can logically jump to this line. If x plus 2 is 0, I don't care what x minus 4 is, I'll have a solution because 0 times anything equals 0. Similarly, if x minus 4 equals 0, I don't care what x plus 2 is because anything times 0 equals 0. So solutions to this equation will happen when I get a solution to either of these two equations. These equations are easy to solve. Subtract 2 from both sides or add 4 to both sides, and I get x equals negative 2, and I get x equals positive 4. It's easy to get lost in the algebra of what we just did. So think about what you just figured out, right? X is negative 2, x is 4 when f of x equals 0. Think in terms of flowcharts. When I put negative 2 into this machine, 0 should come out. When I put positive 4 into this machine, 0 should come out. There's two different inputs that lead to this output of 0. Most people find this second of the two most common types of questions a little bit more challenging. This is harder to solve than this was up here. Solving equations, generally speaking, is harder than just simplifying expressions, which is what we did up here. But really, I'm not so worried about the simplification or the solving of the equations, although those are good skills to have. What I'm trying to teach you is how to go from this question to this answer and this question to these answers. Let's do another one. Suppose f of x equals negative 8. So maybe I'm asked to solve f of x equals negative 8. In other words, I'm told that the output for this function is negative 8, and I'm supposed to figure out what the input is. Well, I can do it the same way I did it over here. I could take my output, which is given to me up here to be x squared minus 2x minus 8, and set that equal to the output of negative 8. And then solve this equation for the input, x is the input, then I'll be done. How would I solve this? Well, maybe you'd add 8 to both sides of the equation to set it equal to 0. And when you do that, a nice thing happens. The negative 8 over here and the negative 8 over here cancel, so I just get x squared minus 2x equals 0. Just like I did over here, I'm going to factor at this stage. However, factoring is a little bit different because over here I have this quadratic trinomial is the fancy name for it. Over here, there's a greatest common factor. Both of my terms, the things separated by plus and minus signs, have an x in them. So I can pull an x out, and I'm left with an x minus 2. If I pull out an x from each of these terms, I'm left with an x here and a negative 2 here. So I get x times x minus 2 equals 0. Instead of x plus 2 times x minus 4 equals 0, I have x times x minus 2 equals 0. Just like up here, I have something times something equals 0. So either the x is equal to 0 or the x minus 2 equals 0. So I get solutions when x equals 0 or when x is equal to positive 2. Again, think about what you just figured out. The question was asking, how would you get negative 8 to come out of this machine? The answer is, well, I could put 0 in and negative 8 would come out, or I could put 2 in and negative 8 would come out. In fact, we saw those two answers up here when I asked you f of 0 and you figured out negative 8 was the answer. And then I asked you f of 2 and you figured out negative 8 was also the answer. Up here, I figured out that the output was negative 8 for an input of 0 and 2. Down here, I figured out that an input of 0 and 2 would lead to an output of negative 8. The same thing, I kind of just did it backwards if you want to think about it that way. In the two examples we've seen so far, we've had two different inputs that lead to a given output. You might wonder if that's always the case. It's not. That's really coming from the fact that our function is a second degree polynomial. But even in this case where our function is a second degree polynomial, terms we'll get more comfortable with later in the class, we're not always going to have two different solutions. Look at this third example here. Same idea, we're told the output. It's really important that you can read this and understand that the output is 7. If this set of mathematical symbols can be translated in your head into this sentence, that's awesome. And then how do you figure that out? Well, we'll take our output, which is still x squared minus 2x minus 8, and we'll set that equal to 7. And actually, this isn't the problem that I want to solve. I want to solve f of x equals negative 9. So I'm going to kind of cheat here and change the question a little bit and solve this one instead, because this is the example that I had in mind. So how would we solve this one? Well, let's do the same technique that we did in red and in purple. Let's set the equation equal to 0 by adding 9 to both sides. I'd get x squared minus 2x plus 1 equals 0, because negative 8 plus 9 equals positive 1. And then maybe I try to factor this, but when you factor it, the same way we did up here in red, I think you'll get x minus 1 times x minus 1 equals 0. So I get a solution if x minus 1 equals 0, or I get a solution if, well, x minus 1 equals 0. Either way, the only solution that I get is when x equals positive 1. What I'm saying is the only possible way I can get negative 9 to come out of this machine is if I put positive 1 into the machine. We're pretty far into this video. I try to keep these pretty short, and really I've only done one of the 3 things that we want to do. We want to look at these input-output questions, but we want to do it for each of our 3 different ways that a function can be presented, with the standard notation, with a table, or with a graph. So you might think we're only a third of the way through this video, but really we're not. Most of the work of these questions comes when the function is giving it its standard notation. You could argue that a big advantage of a function being presented as a table or a function being presented as a graph is they make these 2 most common type of questions a lot easier to answer. Let me show you how. Let's go back up here to where we had a function presented by its table. Let me ask you 2 different questions. Suppose I asked you to evaluate j of 1. Sure. And then for my second question, I'm going to ask you to solve j of x equals 1. If you hadn't seen what we've done so far in this video, you might think these are asking you the same question, or at least something really similar, and they're not, right? Over here, the value of x, the input is 1. So what you're being tasked with is finding the corresponding output. And that's very different from over here, where the output is 1. And so you're being tasked with finding the corresponding input. But the good news is both questions are pretty simple. Evaluate j of 1. This is saying that the input, the x value, is 1. Here in the table is where the x value is 1. What's the corresponding output? Well, it's listed right here. It's the number 2. So all I have to be able to do is come up to this table and see that 2 and be like, you want me to evaluate j of 1? J of 1 is equal to 2. Done. And this question over here in purple isn't much harder. Solve j of x equals 1. You just need to be able to read this and understand that the output is 1. Where is the output equal to 1 in my table? Right here, because the output is the j of x. It wants to know what the input is. What's the corresponding x value? Well, it looks like it's a 0 that leads to an output of 1. So if I was asked to solve j of x equals 1, I would say the solution is when x equals 0. Here is the input that leads to this output. Here is the output that comes from this input. Neither question is all that hard. You're just pulling numbers out of a table. But really where the challenge arises is it's really easy to confuse these 2. If I ask you to evaluate j of 1 and you're like 0, because you see this 1 and you give me this 0. Well, unfortunately, that's the wrong answer. Similarly, if I ask you to solve j of x equals 1 and you're like, oh, that solution's 2, because you see the 1 here and you give me the 2. You have to make sure you're pulling things from the correct column. But if you're comfortable with inputs and outputs, it becomes pretty trivial. And the good news is our third representation, where functions are given in terms of their graphs, isn't much harder. What would the 2 questions look like down here? Maybe I ask you, let's see, I'll really try to trick you here. It looks like the name of this function is h, so I'll say solve h of x equals 5. And then later on, I'll ask you to evaluate h of 5. And all you got to do is understand inputs and outputs. Note that up here, I'm telling you the output equals 5. I'm asking these in the opposite order that we presented them so far. That was the trick I was trying to throw in. Solve h of x equals 5. Understand that the output is 5. The output is the y coordinate, the height of the graph. So where does this graph have a height of 5? You're like, oh, right here. True, but also over here. There's 2 different x values, 0 and positive 4, that lead to an output of 5. Because the point 0.05 and the point 0.45 are on my graph, there are 2 different solutions to this equation. I would say x equals 0 and x equals 4. And that's similar to, but not quite the same, as this question down here, where I'm supposed to evaluate h of 5. Down here, if you're comfortable with this notation, which I recognize takes a little while, the input is 5, the x value is 5. Here's where the x value is 5. I just have to figure out what the output is at this point right here. Well, it appears to be, and again, we'll have to kind of estimate this thing based on the graph. It appears to be some number between 4 and 5, maybe 4.5. Turns out it's exactly 4.5, and we'll learn how it's 4.5 later. But because this point right here is at 5, 4.5, the answer to this question, where I'm asked to evaluate h of 5, I would say that h of 5 is equal to 4.5. The output of 4.5 corresponds with the input of 5. Because this point has a height of 4.5, when it's left and right, its x value is 5. H of 5 is equal to 4.5. Two very similar looking questions with very different answers. Up here, I'm given the output is 5, and I figure out that the inputs are 0 and 4. Down here, I'm given that the input is 5, and I figure out that the output is 4.5. Inputs and outputs that can be kind of confusing, but if you can answer those questions in each of the 3 different formats that we've seen, an equation, a table, and a graph, you got everything you're supposed to get out of this video.